So our goal is to find all the equilibrium concentrations, and our Ka is 3.0 times 10 to the negative 8, and what we're given is 126.0 milliliters with 1.15 molarity of HClO, and it's mixed with 85.0 milliliters of 2.16 molar NaClO. So the Na is just a spectator ion, so it's really irrelevant in the grand scheme of things. So that's just there, so it's connected with the pretty much ion. So our next step is to find the new molarities for HClO and ClO minus. So in order to do that, we have to convert this to liters, because molarity equals moles over liters. So to find the new molarities, we're given 1.15 equals our molarity, which is unknown, so we can just put that x or in whenever you want, over our liters, which is just time. So 1, 2, 3, so 0.126. And to find x, we just multiply these two. So our x equals, we go 1.15 times 0.126. Our x is 0.14 and 3 sig figs 5. So that's how many moles. So then we have to find the new molarity, we do 0.145 over our liters, which is, we add these liters up. So 126 plus 85 equals 211, but it's liters, so we have to do 1, 2, 3, so it's 0.211 liters. And this is our new molarity for HClO, which we can do by doing 0.145 divided by 0.211, which comes out to be 0.687 molar. So our initial molarity for HClO, we can write right here, 0.687 molar. Now, what we find next is for ClO. So what we do is just pretty much the same process. So molarity equals 2.16 equals x over our liters, which would be 123.085, and our x equals, we just multiply these, 2.16 times 0.085, which that becomes 2 sig figs, so 0.18. So then that is over, once again, the same, since you're adding the milliliters, so it's 0.211 liters, and 0.18 divided by 0.211 equals 0.85 molarity. So for our ClO, our initial molarity is 0.85 molar. And H3O plus, that's always given, which is 1.00 times 10 to the negative 7 molarity. So our change, what we have to do next is find our Q. So our Q equals products over reactants. So 1.00 times 10 to the negative 7 times 0.85 over 0.687. And let's plug that in our calculator. So 1.00 times 10 to the negative 7 times 0.85 all over 0.687. We get 1.24 times 10 to the negative 7. And let's compare that with our Ka. So this looks like this is greater than our Ka, since this is 10 to negative 8, negative 7. So our Q is greater than Ka. So if our Q is greater than Ka, what does that mean? That means we go to the reactant side. So we would plus x, and we would minus x, since coefficients are just 1. So, minus x. So our E becomes 0.687 plus x. dash dash, since it's liquid, 1.00 times 10 to the negative 7 minus x, the parentheses, and 0.85 minus x. Now, to solve for x, we just plug this in our equation, which is 3.0 times 10 to the negative 8 equals 1.00 times 10 to the negative 7 minus x times 0.85 minus x, all over 0.687 plus x. And our x equals, let's go to math, numeric solver. I've already plugged all that in, and just literally just copy and paste, then go here, then go 0 equals, boom, alpha, solve. And we get 7.6, since 2 sig figs, times 10 to the negative 8. So x equals 7.6 times 10 to the negative 8. So now if we want to find the equilibrium concentrations of HClO, H3O plus and ClO minus, we can just do concentration of HClO EQ, and that is 0.687 plus our x, which is 7.6 times 10 to the negative 8. And let's set up our next one. H3O plus equilibrium is 1.00 times 10 to the negative 7 minus 7.6 times 10 to the negative 8. And our last one, ClO minus equilibrium, just plug that right in. 0.85 minus, x is minus 7.6 times 10 to the negative 8 equals. So now we can plug all those numbers in. 0.687 plus 7.6 times 10 to the negative 8. That comes out to be, once again, 0.69 molarity, since 2 sig figs. Then let's do the next one. 1.00 times 10 to the negative 7 minus 7.6 times 10 to the negative 8. That becomes 2.4 times 10 to the negative 8 molarity, and this becomes 0.85 minus 7.6 times 10 to the negative 8, which is 0.85 again, molarity. And those are our equilibrium concentrations.